Okay. This thing is going. Looks like we are up and running. All right. All right, guys. The goal of this is to go over the final, practice final. Mainly, I'm going to try to focus on the second half of the final because most classes I went over the first half of it. If you have any questions, feel free to ask them as I'm going along here. And we'll get rolling in a second. Okay. All right. How cool is that, huh? All right, anyway. Okay. So let's pick up around, what's that, number 17, maybe. I'm pretty sure I got through 14 through 16. If not, I'll just start here anyway. I have to go back and look at the chat, so if it takes me a minute to answer your questions, just bear with me here. Okay. You can see I wrote a bunch of notes on there already, so I can explain what's going on and then help you guys out with it. 14 and, okay, so 14 is a question you're going to see a lot, mole-to-mole problem. They're really easy. You can see how I did 14 right here. You start with the 1.2 moles. It's iron oxide. We're just converting it to aluminum. Use the numbers in the reaction. So you see how there's a 2 in front of aluminum. Plug that in on top. There's a 3 in front of iron oxide, or FeO. Plug that in on the bottom. So it's 1.2 times 2 divided by 3. That gives you 0.8. That's the answer for 14. That's pretty easy. I know there's at least like 3 of those on the final because they're straightforward questions. As long as you know the basics of stoichiometry, you can get those. Number 15 is a little more advanced. This is a stoichiometry problem. I think there's 1 or 2 of these on the final. Basic stoichiometry problem. You get grams and you're converting to grams of something else. So in this case, it's 27 grams of copper. The first step is converting it from grams of copper to moles of copper. That's the very first thing you got to do there. The mass of copper is 63.5 grams. So that's why it's on the bottom. And then you multiply by the mole ratio. Doing that, you are converting the copper to chromate. You can see I got the numbers from the reaction. So the 2 plugs in there. And the 3 plugs in there. After that step, you got chromium. You got moles of chromium. So the last step is converting it to grams of chromium. Mass of chromium is from the periodic table, 51.9 grams on top over 1 mole. For every 1 mole of chromium. So in effect, what you're doing is 27 divided by 63.5 times 2 divided by 3 times 51.9. So let's do that really quick and make sure it works. So 27 divided by 63.5 is the first step. I forgot it already. Divided by 63.5. Okay. Times 2 divided by 3. Times 2 divided by 3. Oh, what just happened? I don't know. Divided by 3. And then there's one more step. Let me get rid of that. Here, our last step is times 51.9. So take that number times 51.9. So So 14.7, was that the answer? Yep, 14.7 is the answer. And that's grams of CR. That's your answer. So basic stoichiometry problems, you're going to see a handful of those questions on the test. Most of them are going to be moles of moles or grams of moles. They're not too bad. You guys can handle them. All right, again, if you got questions, just put them in the chat. I'll go back and look at them. If anyone misses this, let them know that they can just always watch this video. It's not a big deal if they miss it. Ooh, wrong thing. 16. I worked out 16 here too. Molarity. Molarity is just moles over liters. They tell you the moles in the solution. They tell you the liters in the solution. So you just plug in the moles on top, liters in the bottom, and you get your answer. So a couple of these in the final, easy. These are really easy, just moles over liters. They can get just a little tricky. I think number 17 is a little trickier than that. And number 17, they give you grams and liters, and they expect you to figure out the molarity. It's still moles over liters. You just got to take the grams they give you, convert it to moles, and then plug it in. And that's all it is. So it's really still not too bad. You just got to do one extra step. I worked this one out already too. You can see on the bottom here, I took the 125 grams. That's given in the problem. It's salt. The mass of salt is 58 grams. So you take 125, divide by 58 to convert it to moles of salt. Let me add that on there. Moles of NaCl. So that's my top number. That's the moles. And the bottom number is given in the problem. That's just 4. So it's 2.5 over 4. Should be about 1/2, 17A. Ooh, wrong thing. Uh, 18. Okay. Solutions problems. So we spent a month on solutions, did a bunch of labs with solutions. Here they give you a molarity of 2. And they're asking you how many milliliters of a 2.0 molarity NaBr solution are needed to make 200 milliliters of a 0.5 molarity NaBr solution. So really you're just plugging in numbers and solving. You can plug them in on either side. So I got milliliters, so I'll plug them in first up here. Well, I guess the proper way to do it would be, doesn't really matter. So we got 2.0. That's the first number given. We don't know the volume of that solution. And then we got the molarity of the second solution. They tell us is 0.5. And then that one is only 200 milliliter solution. So you just solve for V1. So it's 0.5 times 200, that's 100, and then divided by 2.0. We're going to divide each side by 2, so that cancels out. So 100 divided by 2, that's 50. That's it. Here we go. Let's see what you guys. 12 and 13. Yeah, I'll go back to 12 and 13 in a second. Let me finish this last one of these pages here. What is 18? Yeah, let me finish 19, then I'll go back in 12 or 13. 19 is really easy. It's a Gibbs free energy problem. You really just plug in the numbers. The answer wasn't actually, I don't think the answer was actually in here. I don't think any of these were actually the answer. But let me show you how you would set this one up. One thing is keep in mind that Gibbs free energy is in Kelvin. So you might have to convert whatever temperatures they give you to Kelvin, or whatever temperatures I give you to Kelvin. Yeah, so this one's in Celsius. So if I'm setting this up, G is equal to negative 298. That's the delta H. The temperature is degrees Celsius to Kelvin. So what is that in Kelvin? That's just 273 degrees Kelvin. So minus 273. Fix this. The entropy is 100. So you can see this is going to be a really big number because it's 273 times 100, negative 298 minus that big number. This really should be a bigger number. What probably, in this problem, they probably expect you to convert the entropy from joules to kilojoules, and then you can plug it in. So if we do that, converting entropy, so it's 100 joules per degree Kelvin. So that's equal to 0.1 kilojoules. So instead of plugging in 100, it's 0.1. So now this might actually make sense. So negative 298 minus 273 times 0.1. So 273 times 0.1, you guys might know it already, just 27.3. So when you set it that way, negative 298 minus 27.3. Let's see if that gives us the right answer. So negative 298 minus 27.3. Figure that. So 298, it's negative minus 27.3. Negative 325. So that came out to negative 325. Is that one of the answers? Yeah, it's A. So I hope that was the answer that I told you guys. I hope I told you that's what it was for number 19. Number 20, and then I'll go back and do what you mentioned, Colin. Spontaneous reactions, there's only two things you can remember about spontaneous reactions. That's that they release heat or that they decrease in entropy. Like it's a negative number. It's a negative entropy. And they increase, in enthalpy. And they increase in entropy. So here, over here, we got enthalpy. Over here, we got entropy. So what are we looking for? Decreasing enthalpy, increasing entropy. A lot of questions on the final about like what is H, what is S, like what does delta G stand for? Just like if delta G is positive, what kind of reaction do you have? If delta G is negative, what kind of reaction do you have? Hint, it's a spontaneous reaction if delta G is negative. Or it's a non-spontaneous if delta G is positive. But you're going to get a lot of questions about Gibbs free energy, what the symbols mean, and if something's positive or negative, is it a exothermic reaction or is it a spontaneous reaction? Does it release energy? Does it happen naturally? Stuff like that. All right, Colin, you mentioned, let's see here. All right, so Tyler's saying number 8, 12, and 13. All right, let me go back to 8. And I'll do 12 and 13. We'll just go in order here, in numerical order. I know I went over 8 in class, so I shouldn't take very long to go over it. 8. So let's look at what I wrote in here. For the reaction represented by the equation SO3 plus H2O makes H2SO4, how many grams of sulfuric acid can be produced from 200 grams of sulfur trioxide and 100 grams of water? So what they're telling you is that you got 200 grams of sulfur trioxide, which is SO3, and 100 grams of water, H2O. If you were to react those two amounts together, how much H2SO4 are you going to get? And you can see I worked out the answers here. We did this one in class. I do all the steps. 200 grams of SO3. You convert it first to moles of SO3. So I divide it by 80. 1 over 80. I'm dividing the 200 by 80 grams. That converts it to moles. The second step is going from moles of SO3 to moles of H2SO4. So you can see I have H2SO4, 1 mole of H2SO4 on top, 1 mole of SO3 on the bottom. In the last step where you have the 98 over 1 mole, that's the mass. 98 is the mass of H2SO4. So you look at the periodic table, you look at hydrogen, sulfur, oxygen, you add them all up. Depending on each one, how you have 4 oxygens, 2 hydrogens, and 1 sulfur, you add that all up, you'll get 98. And that gives you 245 grams of H2SO4. You can see in the bottom with 100 grams of H2O, I also converted that to H2SO4 because what you're doing in this problem is you are looking for which one's the limiting reactant. And the limiting reactant is defined by which one is less, basically which one makes less of the product, which one is going to make less H2SO4 because that's the amount you're going to make. You're not going to make a 544 grams of H2SO4. You would need a lot more SO3 to do that. So you're limited by the SO3. You would only make 245 grams of H2SO4. One of those on the final, that's it. So you can still get an A on the final even if you miss that problem. Like save this problem for last. Don't do it. Don't take the time. Like go over the easy ones first and then come back when you see this one on the test. And I don't remember where it is on the test either. I don't remember if it's like how I ordered it or anything. Our column was asking about 12 and 13, so let's do that finally. If I can get this thing to work. How's I'm fiddling with this? 12 is same for the reaction represented by the equation. They give it to us there. How many moles of nitrogen are required to produce 18 moles of ammonia? So in questions like this, I think a lot of people get confused because they read it as, how am I supposed to know how to make 18 moles of ammonia? How am I supposed to know that? Let me reset this one more time here. Well, all you're really doing is taking that number, 18, and you're going to convert it to an amount, and that's how you figure it out. For some reason, this thing's not letting me draw on it. Well, the work's already done, so I guess I can just explain it. Well, so for number 12, so you can see you got 18 moles of NH3. That's what I started with. The numbers on the top and the bottom next to that, you have the 1 N2 and the 2 NH3 come right from the reaction. So there's 1 N2 in the reaction. There's no number in front of N2 in the reaction, so that's just 1. NH3, there's a 2 in front of NH3, so I plug in the 2 in front of NH3. I put N2 on the top because I'm trying to figure out how much, they're asking how many moles of nitrogen in the question. So I'm converting to nitrogen from whatever number they give me. They give me 18 moles of ammonia. I got to convert that to whatever moles of nitrogen. So nitrogen on top, ammonia on the bottom, cancel out, knock out ammonia. Take 18 times 1, which is just 18, divided by 2. That gives you 9. There's your answer. 13 is the exact same thing, except they give you grams of chlorine. Or they're saying how many grams of chlorine, excuse me. So you still do the mole to mole part. You take the number they give you. In this one, they give you 2 moles of sodium. We're going to convert it to moles of chlorine because they're asking us for chlorine. And then they ask us specifically for grams of chlorine. So we got to convert that moles of chlorine to grams of chlorine. So I'm going 2 moles of Na. It's a 1 over 2 because in the reaction, there's 1 chlorine for every 2 sodiums. That gives you just 1 mole of Cl2 or chlorine. We take that 1 mole, we bring it down here, times 70.1. Why? Because it's Cl2. Chlorine has a mass of 35 point something. There's 2 of them, so it's 35 times 2, that gives you about 70. So it's 1 times the mass of Cl2, which is 70. And that's why the answer comes out to 70.9. Let's see what other questions you guys got here. 18. Yes. Who is Naruto Charles, though? Who is that? I'm not familiar with that name. Naruto. Number 18. That must be someone else from a different class, maybe. I don't know. Yeah, I went over 18 earlier in the video. I did 18. So if you missed that, you can rewind it when it's done, or you can rewind it now, I think. And you can see the explanation there. There's the work. It's a solutions problem. Once you know the equation, that's the whole thing. All right. If you guys have more questions, please ask them. Feel free to ask them. I'm just going to try to finish the rest of the final here. I got about 15 more minutes, and then I got to get rolling. Let's see. And if you guys have more questions, I can always try to do another one tomorrow, or yeah, I guess tomorrow will be the best time, tomorrow night. All that won't help period 2 because their exam's tomorrow. So 24 and 25, we've been doing this for the past 2-3 weeks, or 2 weeks, I guess. But let's just practice one of them. Or let's just practice a couple of them and go through them. So remember that H3O is the same thing as H plus. That's also the same thing as the term proton. These are all just fancy ways of identifying hydrogen. So the pH of something, the power of hydrogen of something is 9.0. How much hydrogen is in there? Well, one thing you want to remember for the test is the pH equation. So when I first learned this, what I learned was to use the pH equation. And I'm sorry that came out so bad. I have no control over that. When I first learned this, I was told to use the pH equation most of the time, like all the time. And what you would do is you would plug in the pH. So you plug in 9 on the pH side, and then you do the inverse log. So you had to do the inverse log on a calculator, and then you get the hydrogen ion concentration, the negative inverse log. You get the hydrogen ion concentration. So you do it all with a calculator. Later in college, I realized that it's like there's this relationship between pH and the concentration. Again, this doesn't work with more advanced pH questions. Like if the pH of a solution is 9.8, what is the H3O concentration? Well, then you got to actually use the equation. But luckily, I didn't put that on the test. I didn't put that in the final. All right, I kept all the pHs whole numbers, so you don't have to worry about that. Anyway, the relationship here, as we all know, is just it's 0.9 or negative 9. pH of 9, due to this reaction or this equation that we see on the right, it's a negative log. It's related to a negative log, so it's 1 times 10 to the negative 9th power for the hydrogen ion concentration. So if you're given in number 25, they give you a base. And that changes things up a lot, because what they're telling you with that is that the OH concentration, not the H concentration, but the OH concentration, which is like the opposite of H, is 10 to the negative 5. And we just have to keep in mind that the two of them, hydrogen and hydroxide or OH, are balanced to both be 14. So if it's negative 5, then H must be negative 9. They both have to come together to be negative 14. So what is the pH of that solution? It's correlated to the negative 9. It's got to be 9. Now, let me see if you guys got any specific questions. Let me do 26, and I'll see what questions you guys got. Bronson-Lowry acids, falling reaction. Okay, so Bronson-Lowry, we got the Arrhenius definition, which is either releasing hydrogen or releasing hydroxide. We got the Lewis definition, which is all about electrons. And then we got the Bronson-Lowry definition. The Bronson-Lowry definition is all about either releasing hydrogen or accepting hydrogen. Acids release hydrogen. Bases accept hydrogen. So we're looking at it here. So what are the Bronson-Lowry acids? So you can see CN goes to HCN. So what happens? It accepted a hydrogen. CN's a base. Water, it lost a hydrogen. It gave up a hydrogen to CN. So CN could become HCN, or hydrocyanic acid. So that's your acid because it gave up a hydrogen. And you can see the conjugates here. Those two are conjugates, and then H2O is conjugate with OH. Those are the conjugates. If H2O is an acid, OH is a base, or the conjugate base. If CN is a base, then this guy is a conjugate acid. So which of the following are acids according to that? We got water, HCN, D. All right, let's see what questions you guys got here. Oh, Mark. Okay, hey, Mark. Yeah, this is gonna be a video, so you can always come back and stop. Like once this is over, you can come back to Modern Science, the YouTube channel, and just check it out. 21 through 23, thank you. I'll go back and do that in a second. So yeah, if you can't rewind now, then you'll be able to once it's over. All right, so yeah, I guess I skipped 23. Let's do that really quick. Yeah, okay. So I put these on the test because I was thinking that they're pretty easy calculation problems. All right, so 21, how much energy does a copper sample absorb? Has energy in the form of heat. If it's specific heat, and once you see that phrase specific heat, you should know what to do here, is 0.384. Its mass is 8, and it's heated from 10 to 40 degrees Celsius. So we got 40 minus 10 for our temperature change. We got a mass of 8. We got a specific heat of 0.384. And you just solve for Q. And that's it. So you multiply the three numbers, just 0.384 times 8 times 30. That'll give you your answer. So these are easy problems. I didn't do anything type of tricky conversions with these problems when I put them on the test or the final. They're all straightforward. 22, same idea. You got in this one they give us the kilojoules of energy, so we're going to plug that in. So that's 500 is going to be equal to N times, fix that, N times 40.79. There's the setup for that one. So when you get N is going to be in moles. And then we got to convert to grams. That's what we have to do there. They tell you it's water, so the mass of it is easy. It's just 18. So let's work this one out really quick. So to solve for N, it's 500 divided by 40.79. So 500 divided by 40.79, that's 12.2. So N is 12.2. That's moles. All the answers are in grams, so we got to convert that to grams. It's grams of water for every 1 mole of water. Mass of water is 18, so 12.2 times 18 times 18, 220. That's A. All right, once I'm done with 23, I'll go look at what other questions you guys got here. Yeah, conjugate acid bases, pretty straightforward. Just look for the ones that look alike. And this reaction, you can see that the HClO3 loses a hydrogen. It gives up a hydrogen, so it must be an acid. NH3 gains a hydrogen, so it must be a base. NH4 went from a base, so it must be a conjugate acid. And then ClO3, it lost an acid, so it becomes a conjugate base. The final is about 60 questions. All right, the formulas. I was actually thinking about this on Friday. For the formulas, I'm going to, I'll give you a formula handout. I'll have like a little handout that I'll give you guys when you take the final. So I'm not going to tell you what formulas will be on there, but the ones you need will be on there. So there will be a handout. I will give it to you before you take the final. So when you guys are sitting down, getting ready to roll, I will give you a formula sheet. And you can also write all your work on the formula sheet too. All right, let's close this out, and then that should be about it. Guys, just study this practice final. Like if you see topics on here, and like if you're having trouble with some of the topics, that's when you go look at other sources. But really, just focus on going over this practice final. Everything that's on here. Like if you like the 27 is a balanced, like looking at balanced reactions, like being able to balance. So maybe go practice balancing. Look at like Khan Academy, like how do they explain balancing? Then go watch one of those videos, because a lot of you guys have trouble balancing, and there are balancing questions on the final. I put like 3 of them on the final just because I thought they were on the easier side. So if you do have trouble with it, just review that. I would recommend Khan Academy for that. So in 27, which of the following is correctly balanced equation for the incomplete combustion of heptene? Can you guys put in the chat what the answer for 27 is, and I'll make sure that whatever the answer is correlates to this. So let's see here, because I don't have the answer sheet. I forgot what they were. I didn't bring it with me. I was so ready to get out of there on Friday. So I know B is not it, because right there, O is a part of that that set. It's diatomic. O is diatomic. Like it's O2. It has to be O2. So A is an option, C is an option, and D is an option. All right. It's combustion. Combustions make CO2 and H2O. So it can't be D, all right, because that's carbon monoxide, not carbon dioxide. All right, so it can't be D. And it can't be A because it's making some weird stuff. I can't even read that. Hydrogen gas and something else. So I'm guessing it's got to be C. Let's see if you guys. Woo. Okay, one of you said it's D and one of you said it's A. So like make up your minds here. What's the answer for 27? Someone said D and someone said it's A. According to my calculations, it's C. So like I can't. I'm looking at this here and I can't see how it's not C. Like it's got to be C. So if I'm wrong there, or if the paper's wrong, like I am almost positive. Like I would bet money on that. Maybe I read the paper wrong. That's my guess. Anyway, it's not D. Combustion. Remember, a combustion reaction, it's got to be CO2 and H2O. Combustions always make CO2 and H2O. That's like you don't even have to look at how to balance this. It's CO2 and H2O being made. Done. I mean, there are combustions that make carbon monoxide, but let's not go there. Like we never got into that. Let's not go there. Let's not get into all that. Carbon dioxide, H2O. Let's not worry about it any other way. Okay, so I told you guys it was D. Well, my bad. D is possible. D is technically right, but based on what we've learned, it should be C. Like I would go back and say whoever put C is right. All right, let's close this out. So we got how many atoms are in 0.075 moles of titanium. That's just Avogadro's number. So Avogadro's number, 6.022 10 to 23rd. That's how many atoms there are in 1 mole of any substance. So 1 mole of anything. So we just do 0.075. And let me show you guys how I would do this. Times 6.02. That's what I would do. So 0.075 times 6.022. And then just look for wherever 4.5, wherever there's 4.5 something. So that's got to be D. That's the only one with 4.5. Done. Move on. Don't worry about the exponent or anything. Just Main answer. Done. All right, so here's another one of those mole to mole problems. Like 29, this is a mole to mole problem. These are easy. All right, these are easy stoichiometry problems, which is why I put them on the final. So we got 3 moles of KClO3. We got to convert it to oxygen. They're asking for oxygen. Oxygen is O2. We want to get rid of KClO3. I look at the reaction. I see oxygen as 3. Boop. I see KClO3. Boop. 3 times 3 is 9. 9 divided by 2 is 4.5. A. All right. Let's see. Almost done here. You guys can go study for period 2 final. Good luck with it, by the way. We got one more week of school here, guys. Oh. Okay, another mole problem. Or this is moles to moles to grams. So let's write that out really quick. Moles to moles to grams. Or mass, however you want to say it. So you take the number they give you, 8 moles of iron. Iron's Fe. Ooh, what is that doing? There we go. I'm sorry, this thing's I guess I got too many things running on here, so it's taking its sweet time. Like it might have just crashed. I'm not sure what's going on. No, there it goes. Okay. Like it's not working for me. Sorry, guys. It's just technical difficulties. There we go. Moles of Fe. All right. They're saying for grams of iron oxide. So first thing I'm going to do is convert this from iron to iron oxide. I want to get rid of the iron. Iron up here is 2. So I put a 2 in there. FeO is 2. That's easy. So that's still 8. The next step is convert it to grams of iron oxide. I don't know what the mass of iron oxide is. I forgot what iron is. Oxygen 16. It's some decent sized number. So I'm just going to Google it really quick. Mass of FeO. 71. Make sure that's right. Yeah, FeO, right? 71.8. If I had a periodic table, I would have added it up. 71.8. That's for every 1 mole of FeO. So really all this question is 8 times 71.8. 8 times 71.8. That's 574. And that's grams for grams of FeO. That's D. Right, let me see if you guys got any questions here. Any comments? How much money? Can I add 1 point to everyone's extra credit tests? You originally told us the wrong answer. No, you know what? I will curve it probably by like 2 points because there's like 2 issues with this. So yeah, whatever the percentages are for each question, it'll probably be curved by like, so let's say you got like a 85 on that extra credit test, on the practice test, you'll probably get an A. It'll be a 90, and you'll get the 5 points extra credit. I'm going to do that this week. So you know what? You all can thank Angelina R for that. Okay, the curve, you guys have seen this curve many times before. Here we have a solid. Here is where it melts, then becomes a liquid, vaporizes, and then becomes a gas. So what are they asking? Which part of the curve represents the points at which a liquid water begins to change phases to become water vapor? So that's point D. Easy question right there. I'll also keep in mind that all of the pictures, all the illustrations or diagrams that you see on the practice will be on the final. No more though, just these ones. Like I'm not going to put any others. It's just these ones. I'm going to ask different questions, but it's these guys right here. So we got solid, liquid, gas. Triple point is here. Critical points up here. Keep in mind that the critical temperature correlates with the critical point, and the critical pressure correlates with the critical point. So which letter represents the triple point? That would be A. You guys probably knew that though. And then we've seen this before. On the left, we have a exothermic reaction. On the right, we have a endothermic reaction. That's absorbing energy. Positive delta H. So which reactions? And endothermic, that's reaction B, because we're starting at a low point. It's absorbing energy. The products require energy to go up higher. All right, guys, that's it for me. Let's see here. See if you guys have any other questions. Yeah, so if people miss this, just let them know they can watch the video. If it really would help, I'll do it again tomorrow. I had 11 people in here today, so that's good. Thank you for coming. Thank you for watching this. I hope you guys do all well in your finals. Hope you knock them out. And if you guys have any questions, you can email me or send me a reminder, whatever. All right, Liz is saying wait. Who's Liz? Who's Liz? I don't know any Liz. I don't have a Liz in any of my classes. I'm waiting for you, Liz. I'm waiting for your question. Like I'm just sitting here staring at this computer screen, staring at your weight. So what am I waiting for? Oh, hi, Lindsay. How's it going? Yeah. I'm glad you came. I hope this helped, Lindsay. If you have a question, please ask now because I'm about to sign off in about 5 seconds here. 3 seconds. Okay. Have a good night, guys.